here. It's quite a lot of people. Good to be back in person, to be honest. Speaking to a camera and looking at faces still here is pretty boring, to be honest. So yeah, today I'm going to talk about GraphQL. More specifically, how you build a GraphQL API on top of your Spring Boot application. So this is very Spring Boot specific, but the libraries and the underlying code you can also use in other Java applications. To be very honest, all the frameworks that I'm going to talk about are based on a basic GraphQL Java library, which is just plain old Java, actually. So if you have a Java application, you can just use that as well. Without further ado, let me introduce myself. I am Sohan. I work for Capgemini. And I live in a very beautiful city called Utrecht. And that's not Taj Mahal. That's Victoria Memorial, where I actually from. It's in Kolkata, India. You can find me on any social platform. I do have a Mastodon, if I'm pronouncing it rightly, but I'm not really using it yet. I still want to see how Twitter goes down. So let's see how that goes. So what's in store today? I'm going to talk about a little bit of GraphQL. How many of you are aware of GraphQL, what it is? Quite a few. Cool. Then my life is a bit easier. Then I'm going to talk about what are different frameworks we have in Spring Boot space. And I'm going to talk about, at the end, how they compare among themselves. So I'm going to try to give you a little bit of perspective. So if you are busy or thinking or even build already a GraphQL API, this can give you a different perspective. And the space is very evolving right now. So all the libraries are very fresh. And to be honest, Monday I was updating my demos, and all builds failed, because they are releasing every 2 months, and they are breaking releases. They are solving issues. They are putting new code. So it's a very interesting space right now. And also, all the codes that I'm going to show you here at the end of the presentation, you can find it in my repository completely. That's not a problem. Before I begin, let me tell you a story. We are all aware of REST APIs. So once upon a time, a project I worked in had a simple data model, provider, and they provide services. Nothing very tricky about it. We created services on top of it. There were endpoint to retrieve services. There were retrieve providers. But then came the requirements. Can we have only provider name associated with the services? Yes, you can. You can call the services API. It gives you the whole provider. But no. We don't want to expose all the information on that API. OK, so we built one for you. Then they said, can we have services associated with the provider and with some specific attributes, and only the providers? And the list went on and on. They wanted so many endpoints that we have created a monstrous REST API endpoint hell. You might be asking why we did that. Maybe there was API design issues. Yes, there was. At the very beginning, we didn't have all the requirements. But it evolved over the time. And with evolution, with the pressure of releasing, we ended up creating endless endpoints. And then came to rescue GraphQL. I'm going to, in a little bit, show you how GraphQL works, what is the core of it, and how you can build something on top of your existing infra. So our challenge was requirements coming in, and we were creating APIs. We wanted something which is supported by our existing infra, so basically your services, your repository, and your Hibernate code, or even if you're calling an external API, we don't want to change that. We just want to add new features on top of it without much of a hassle. And that's where GraphQL came in to rescue. So GraphQL basically is an aggregator. It builds on top of your code, repositories, APIs, whatever you name it. And it gives you the opportunity to query that data. When I say query, it also comes with a schema. Just like a database, just like any data model, it defines you a schema, And on the top of the schema, you define which all queries, which all mutations, or CRUD operations are allowed. And that's what interests the community a bit. It is, as I said, backed by existing data, and it was also designed by Facebook a long time ago, and it was open source at 2015. It didn't got much traction. To be very honest, it's still very low from the perspective of how REST is popular, but it has its niche use cases. Before I go ahead, I'm going to warn you, this has nothing to do with GraphDB. Although you can create GraphQL-ify on top of GraphDB, but that doesn't mean they go together always. And it is not a replacement for your REST. Even though we had problems with REST, REST has its use cases, GraphQL has its use cases. And it will also not magically solve your API design issues. So be careful when you're choosing a technology. Everything sounds nice and shiny, but it is not always applicable to your use case. Just like Venkat was not Venkat. Sabyasachi was talking about. You look at the problem, not the solution, at the keynote, if you guys were there. So as I was saying, there are 3 major parts of it. Okay, 4 if you take mutation as well, but I'm going to talk about the query part a bit. So it comes with a schema. It looks like this. Actually, why I'm showing this? Let me show you the code. And this goes down. Can I go? Oh. So it looks like this. You define what all this schema contains. Right now, my schema contains query and mutation. By the way, you can separate that out as well, depending on how big your data model is and how major your operations are. Then you define which all queries I'm going to give and which all mutations. Mutation in GraphQL term, what all changes on the data you can do. And then you define your data model, which looks like simple class definitions, if we are aware of. So you tell, this is my service, which has provider, and that's my service, which has, this is my provider, which has number of services in it. And that's all. Once you give that data to any consumer, they should be able to define all the queries on top of it. You guys are aware of OpenAPI standard, Swagger? So this is very much similar to that. There we create a huge YAML file with all components, schemas, post, get, put. Similar to it, this is as well. So in Postman, you can import the OpenAPI YAML. Here, also, you can import that, and the Postman will create your queries and mutation on top of it. Normally, most of the framework that I'm going to talk about comes with a GraphQL interface. What is that? I'm going to show you a bit. Is my server running? Yes, my server running. So it is simply, either you have to enable it using an application properties in Spring Boot, or it is by default enabled, and you have to disable it for production. But it gives you a graphical user interface, which helps you to build your knowledge on GraphQL, how you create something, how you query something, how does the results look like. So it has auto-completes like, before I go there, it gives you the doc on what can you do with the GraphQL, and what are the queries available or mutations, and if I do that, what do I get? So for example, if I'm going to do a provider ID for name, let's say I'm only going to get the ID. So it gives you an autocomplete and tells you which all things are already there. So if you're very new to it, this tool helps you to build the knowledge of how you do it. So let's say I want to get descriptions, and I want to get services name. So if you run it, you get the result as is. If you look very closely, the result has a specific structure. It starts with the data, and then what you queried on, and then the attributes you wanted. That's the power of GraphQL. In REST, you get all or nothing. in GraphQL is what you ask for. So if you only have to show provider name on your landing page, you query that. After logging in, if you have to show the ID and the region where the provider comes from, you can. Then you fire another query where you need those attributes. Puts a little bit less load on your HTTP communication. A little bit of bytes, but if you think about if you have a million users concurrently hitting your website, this is a big win. And that's why Facebook invested on it, LinkedIn uses it, and a lot of other companies who has heavy user, and on those applications, they have different way of displaying the same data. Let me go back to my presentation. So that's what a schema looks like. That's what a query looks like. And that's what the results look like. For mutation, you just say mutation and the mutation operation with what you want to do. As I said, the landscape is quite huge. There are people using it. What it helps you to aggregate on a hierarchical data. It is strongly typed. You cannot ask for something which doesn't exist. The GraphQL server will tell you upfront. You don't need to implement any kind of validation whether the ID is ID. It evolves without versioning. We are all aware how we do versioning in REST API. There are different methods, header, in your URI. Here, you don't have a version. You evolve with your deprecating the attributes or deprecating the queries. And then, yeah, slowly the consumer also takes up that. So you don't need to throw up 500 or 404 if that doesn't exist. There are a few things you can do advanced. I'm not going to go in details. GraphQL Java has a very, GraphQL.org has a very extensive documentation on how you define a schema. And there are a lot of things you can do. You can define your own input parameters. You can define your own data model. You can define your aliases. And maybe an interesting topic. As I said, you can also do it from Postman. Yeah, this is quite visible. So if you look at left-hand side, I have a query which says a left table, retrieve the services, and I have a right table or right section where I'm going to display the services by ID. But what I used is a reference my object. So you are actually executing two queries in this example with one HTTP call. And also defining your common object model that I want for both the queries, name description and provider name. And when you run that, you get just like it. As I said, it will be a data with your query alias. And if you go down, you have the other data with the query alias. So if you're writing a JavaScript application at the front end, you can assign these aliases to your data object or the visualization object that is displaying the data. So you alias it, your one call, and you get the things only that you want to show. It gives you int, string, Boolean, ID, and float. And if you want to create a complex object, you can create basically using those default data parameters or data types. You can define list, not null. List is with the array symbol, not null with an exclamation mark. So then when you're querying, the GraphQL server will automatically check whether you are providing that parameter or you are providing it correctly or not. You can define interfaces also. This is a little bit different interface. If you look at the picture, all the implementation also define the same attributes. It is not from the definition perspective. It is from the querying perspective. So if you're querying a droid, so you can also say, give me the character object. I don't want the full droid object. So from the query side, it uses the inheritance rather than from the schema side. It's all nice and cool, but you need to be very careful about using this. As I said, you need to look at the problem which you're solving. GraphQL is not a silver spoon or a golden spoon, which will solve all your problems. So you need to be very careful about n+1 queries. Who all are you aware of n+1 problem? Very few. I'm going to come back to it. I think you all know. You all have encountered if you have coded in Hibernate. It has complexity in caching. Because it aggregates, it's very difficult to identify what the consumer is going to query next time. So you need to be very careful what kind of caching you implement. And that mostly depends on the lower part of your infrastructure, which actually gives you the data, not on the GraphQL, which aggregates the data. But there are possibilities to cache it. Some of the frameworks I'm going to talk about give you that opportunity, but careful about it. Even though quite a lot of people are using it, I had a big slide of names. Community presence is very low. Stack Overflow is not overflowing with questions. So you have to be a bit careful what you're going to find. So I was saying 2 days ago, I updated my libraries, and everything went red. It took me a while to figure out how to solve them, because it was hidden in one of the GitHub issues in their new release, how to solve that. So it is very difficult to find solution to it, but it's not scarce. It's scarce, but it's not there. Pagination is a painful thing in GraphQL. Normally, in REST, you can do the pagination either in the URI or in your response itself. GraphQL, on the other hand, you have to define your schema in such a way that it supports pagination. So it's onto you rather than onto the framework. So by that, I mean it's not really handy to do it, unless you know what you're doing. It also have problems with file upload and download, but I don't think GraphQL is for file upload and download, to be honest. OK, enough about what it is. Let me show you some of the frameworks and give you an idea about what is there for you to use. The first one I'm going to talk about, but keeping in mind a simple base example. So I have a simple provider and repository, provider and services, which follows the same pattern of familiar Spring Boot application. You have a JPA repository, you have a service, and you have a controller exposing different sorts of REST endpoints. So keep that in mind. Every library I'm going to talk about is based on this structure and how it evolves from there. So first library is GraphQL Java. This is one of the oldest. And to be honest, this is the base for every other framework. And slowly, I'll try to explain what they changed. What you need to use it in Spring is an extra dependency along with the GraphQL Java. But it's archived. It's archived because Spring came out with Spring GraphQL this year, and they discontinued it. That doesn't mean it went away. It means that they will not have any more releases. But it's still there, it's still valid, and still works. How does it look like when I create a GraphQL on top of it? Remember the first thing I said, you're keeping your infra same. From service onwards, I'm not going to change anything in this application. And that is true for all the libraries I'm going to talk about. There's a lot of things happening in the front part where the GraphQL is exposing or aggregating the data. There's something called data fetcher. Data fetcher is something which fetches your data. Pretty simple or pretty trivial. Data loader is also something which fetches your data, but it has a very specific use case. When you have a hierarchical structure and you're querying a dependent child, then the data loader comes into the picture. And every framework I'm going to show you today has data fetchers and data loaders. There are a few more components which needs to be defined when you're creating a GraphQL Java with this library. You need to define how to parse your schema. You need to define where to find those queries when somebody is trying to retrieve services or providers. And that goes on and on. It's quite a lot of boilerplate text, actually. Code text. There. So you need to define a component which actually loads all your data. it actually initializes the schema at the time of initialization in it. And then you need to define, if I'm doing a mutation, I'm doing an add service, call that. Define query services, do that. If I'm querying providers within a service, do that. So there is a lot of boilerplate code you need to do for GraphQL Java, if you do it. I'm already 20 minutes, and I'm not even half. I need to. OK. Next one is Java Kickstart. This is very much alive. They actually updated last month, to be honest. And you need to have two dependencies to work with Spring Boot. One of them is the starter, another one is the tools. This is also based on GraphQL Java, the previous library. So everything goes on and on. You'll see the simplicity of this model. So there was a lot less boilerplate code. They concentrated on, let's build the schema at the runtime. We don't need to provide. If you put it in a specific path in your resources, we'll pick it up. They also created interface-driven definition. So rather than you're saying when the schema is query and services, call that, rather than they said, if you implement a query resolver, and if you implement it on a service entity, I'm going to invoke it automatically. You don't need to do anything. So define it as a Spring managed bean. I'm going to pick it up. So how does it look like? No. So yeah, it looks like this. It says it's a query. And if you are invoking services, so it matches the name of your query, the schema that you define. So it has to be services, same string. And if you define a method services, it'll automatically match it. So it'll do everything underneath for your code. You can also define entity-level mapping. So if you say, if somebody is querying provider and they also want the services associated with it, do it like that. So a lot less boilerplate code, lot easier to implement as well. Moving on. Did I? Yeah. DGS framework. This came out 1.5 years or 2 years ago. This from Netflix. They open sourced it, yeah, mid-pandemic time, I think. This is also quite active. They also released very often. The last version, it's 5.4.1. I ran into quite a lot of issues with this. And this is where I had to spend quite a lot of time to fix it. And it was hidden in one of the issues. But anyway. So they created this. They open sourced it. It is a bit different than the previous two. This is more annotation-driven. So as I was saying, if you go further, you will see how the picture gets simplified for you. So every step, every new framework actually took the time to invest to find what are the pain points and how I can simplify things. So this is an annotation-driven framework, just like Spring Boot we are quite familiar with. You define an annotation, you map your methods to mutations or queries or entities. Same story again, not changing the infrastructure at all. How does it look like? Actually, I was running that application when I showed all the so it looks like that. When it's a, you need to define it as a DGS component, which is an abstraction on top of Spring Managed Bean. And then you define on the annotation what kind of thing is that. Is it a query? And what this query is going to do. And then you map it. And yeah, I separated the provider and services. But yeah, it depends on how you want to implement it. For me, it's more readable. Then, the Spring GraphQL. This is the newest addition in this world of GraphQL in Spring Boot. They released, I think, May or April this year, and it's still 1.x versions. The 0.2 came out, I think, a month ago or so, something like that. You just need one dependency, and it's ready to go. You can build the POM from startspring.io as well. If you search for GraphQL, it will automatically add stuff for you. It's a bit different. They followed the same way how we are used to build REST API in Spring Boot. So you have a controller. In the controller, you define annotations on what this controller is doing. And yeah, the annotations are query annotation, mutation annotation, similar mapping. There is also batch loader registry mutation mapping, but I'm not going to talk about that because N+1, I'm going to go deep into data loader a bit. So then you know. To give you a sense of feeling how it looks like, so this is my controller, and you see it maps it has a schema mapping annotation, and you say it's a query. It also has a direct annotation. You can also say mutation mapping rather than schema mapping, mutation, value something. So you also can shorthand this a bit. Now, the best part. Here I'm going to make some judgment calls. It's my personal view, so it doesn't have to be your view as well. But I would like to give you a perspective on what I did or my findings are. Go find your own journey. That's the best part of it. So first, data fetcher. As I said, data fetcher is to retrieve your data. So if you have services, you're querying the database or querying an endpoint and get the data back. What you need to do for GraphQL Java is you have to register it with your schema, and then you have to write a piece of code which gives you a data fetcher of that type. So if you look at the bottom method, it tells you about what it does when it actually tries to query services. For Kickstart, a little bit different. You define a component, but you implement a query, as I showed you also. And then you define the method name same as what you defined in your schema. In DGS, you define the DGS data annotation and define it's a query and where this query maps to. Spring GraphQL schema mapping. N+1. We all know these kind of entities where we define a one-to-many or many-to-one or certain kind of relationship. Then you query, find by ID. You would expect a query like this. But if you're not careful enough, you get a query like that as well. And that is 1 + 1, and hence the name N+1. Think about if I do find all services, and I have million records of services, it will do a million + 1 query for you. It's very known issues when you are using JPA and Hibernate, and there are lots of ways to solve it. But in GraphQL, you cannot do that because GraphQL queries attribute by attribute. So you need to define something which handles this for you. So JPA Hibernate won't be able to do it. So that's where the data loaders comes into the picture. It's a bit more, how do I say? Quite a lot of code you have to write. When I say quite a lot of code, it's not one-liner. You need to write a few methods, a few beans and tweak them together to make it work. But basically, what it does is all the frameworks tries to define a bean which is responsible for a specific query. So if you are querying providers for services, you define a specific data loader which does it for you. There are two ways in all the frameworks to do it. One is a batch, and one is a mapped. Maps for every ID another ID. Batch is just takes all the IDs and queries it together. Both work similar ways, but map is more easier because you can match for which service I called which provider. So that is more type safe or safe results back. I have both the examples. In Spring GraphQL example, I have mapped. For all others, I've used a batch. So at the end of the presentation, if you try to look at the code, you can also compare it, how that goes. all those framework uses the same way of doing it. You will have a completable future where you pass all the IDs, and the completable future will execute it at the end of the day. So this is how it looks like in GraphQL Java. In Kickstart, you need to do a bit more. There's a lot of code there. Don't worry about it. It's all in there in GitHub with proper testing, so don't worry at all. So you need to define a component which defines a batch loader, and then you need to register it, and then when you are querying it, you need to load that data loader to call it. In DGS, it's a bit simpler. You define a data loader class, and you name it. And at the time of querying it, you load the data loader in the memory with the name. You can also load it. You see the get data loader providers. You can also load it by the class name itself. So you don't need to pass strings. It can be type safe as well. There's a catch, though. DGS platform says you need to have a query or a method which takes a list of IDs to give you back all the providers in this case. It doesn't support parallel calls one by one, although you can yourself implement that using a completable future as well, using Mono or Flux. The Spring GraphQL gives you pretty similar way of doing it as well. So you define a class, and you define at the time of loading this bean, what is my data loader and how are you going to do it. And if you look closely, it uses a map entry, and this defines this is a map data loader than a batch data loader. Error handling. Do you know GraphQL always gives you 200? No? GraphQL always gives you 200. There are no 500 in GraphQL. Let me show you. Actually, it's quite funny. I found this very funny. So do I have an example? Yeah. It's the 85. If you see here, it's a status 400 OK, although I have actually an exception because it cannot find the provider ID. That's what I like about it. This is I belong to the liking group of it. Some people don't like about it because they want to handle the way exceptions are handled normally in a web API, like SOAP or REST. So you get an exception, you handle it. But here, it is part of your response itself. So the response data structure gives you the opportunity to put extra information about your error. Just like it gives you information about your results, it gives you information about your errors as well. So how do you implement in GraphQL Java? You need to implement a class which has different attributes, and you can pass it along if this happens somewhere. In Kickstart, they give you two options. You guys are aware of exception handler, controller advice in Spring Boot? They give you an option to do that as well, so you need to switch it on using a property, and then you can do it similarly as you would handle an exception in a REST call. But you can also implement an interface and handle it there, so depending on what you are familiar with or feel comfortable with. DGS, it's a lot of code there, but gives you a method which you can actually intercept and do something about it with your error code. So let's say you're throwing an error within your repository or your service that provider not found, or you ran into, I don't know, null pointer exception. And then, depending on what exception you get, you can parse it or send it through what you can do with it. Spring GraphQL, also very similar. So you can also intercept a method and do the exception handling there. 2 months ago, this documentation was not part of the main doc. So that's why I said about maturity at the beginning. They are still evolving. I could implement the exception handling with Spring GraphQL, browsing through GitHub issues, and Stack Overflow. Took me a while. You don't have to because it's in my GitHub. Clients. We're talking about servers, but there are consumers as well. So when you're building a GraphQL API, you might have a consumer which have to consume this GraphQL API. I'm going to talk about the Java part of it. And the JS part is pretty much similar, but the Java part, because it's JFall, let me concentrate on that first. There is no defined way in GraphQL Java. You do really need to parse it as you want. So you need to define the whole entity structure, or you need to parse the string that you get as a JSON response. So you cannot really do that in a defined way in GraphQL Java. There is also no defined way in Java Kickstart. There is a web client library, but that helps you to call it. It doesn't help you to parse what you get back. So you cannot map your response to an object structure. And that's, same as querying, same as JSON parsing. It also doesn't help you to create the query. Creating the query also becomes your job to do string parsing. DGS, on the other hand, provides a plugin. They created themselves a Gradle, and a community created a Maven plugin. And using that plugin, you can generate all the objects that you need. You can even generate the query that you need to do. So it brings down a lot of string parsing, JSON parsing out of your hand. And you can just concentrate about what you want to query and how you want to use that result, not about parsing and changing all of that. And there are ways to do it. That's there in the GitHub as well. Spring GraphQL doesn't provide you anything. There is a way to invoke it, but you're still down to parsing and creating your queries and parsing a response. Testing and code generation, as I said, they do not have anything. DGS has a component which you can actually generate your objects, and that gives you also opportunity to test your code. So if you're writing Springboot test or simple integration test, that also can be used using this plugin. Spring GraphQL doesn't have it, but they give you a very easy way to test your GraphQL endpoints. So you can annotate your tests along with Springboot test and auto-configure. Then you can pass a query, and it gives you back a result. So you can validate whether your results are good or not. Helped me a lot, actually, when I updated my library and all went red. I'm very glad I wrote some tests around it. So final words. Subjective, to be honest. This is there since long. So if you are not in Spring Boot space, but you still want to implement GraphQL on your project, this is a library you can use. And basically it can work with any Java libraries. There are no clients, though. You need to, when you're creating your clients, you need to do a parsing of JSON and all of it. Bit matured, but it still has its boilerplates. And DGS, it's there. I'm really not too much sure about the maturity. It's alive. People are using it. Netflix is behind it. So I'm quite confident that this will go ahead. The code generation part I like about it, because you do not need to worry about all the data structure you have to build, all the queries you have to parse. And this is just released. It's also based on the similar idea about no boilerplate code, minimize the effort from the developer, focus on what you want to expose rather than what you want to build. But there's no code generation as well. So I choose a combination of DGS and Spring GraphQL. Spring GraphQL for exposing it, and DGS to consume it, because you have the opportunity to generate your codes and all. I still have a few minutes, I think, yeah. Nobody's showing me anything, so I'm going to go ahead. Do I have the client? Do I have the client? Where is the client? No, I don't have the client open. Let me show you the client a bit. I mean, where is my, there. I think Yeah, here. So using the schema, it generated all these classes to make it easier for me to query GraphQL. If I move to my other branch, which doesn't use this, and you'll see a lot of reds because, yeah, you need to build everything. I created my own response data model. So which has provider data, which has a provider by ID, and then if you go into the provide service, you have ID, name, description. It goes on and on and on. And not only that, I have templates to query those data. I use mustache, so if you pass provider ID, it will replace it, and then it will generate your query. I have to go through a lot to, it's okay, but it's not really easy to remember. So if you have a lot of queries and mutations, you will end up creating a lot of templates and resolving them at the runtime, which results in more problems than you can ever have. As I said, slides are there, codes are there. And questions, comments, yeah, go ahead.
Do you have any rule of thumb for choosing between when, for example, an open API-based API would be useful versus when a GraphQL?
My rule of thumb is if you have a hierarchical data. If you're exposing a hierarchical data using your services, GraphQL could be a way to consider it. So if you have hierarchical data, A to B, B to C, C to D, and you're exposing it, that's my rule of thumb.
And I have a second question, if that's okay?
Yeah, go ahead. I'll come back to you.
Okay, yeah.
Yes?
So GraphQL sort of like limits the number of fields that the client gets back.
Yeah.
But how do you then do the database? You have to query everything, all the fields.
Yeah. Yeah. That.
And scale it down again or something.
Yeah. That's what the GraphQL server does for you. So GraphQL server checks what's in your query and your mutation, and it squeezes or expands it depending on it. But your backend is still querying it. So don't get me wrong. GraphQL is an aggregator. So all the calls that you're doing to your database or your backend API, getting all the data back, unless you are minimizing there as well. The GraphQL only does is hides or opens up what you asked for.
Is there a way to optimize queries to the database, to only fetch the database?
Yes, you can. Then you have to do it on the repository level or on the call level. So the place where you're calling the backend API or your database, you can cache it, or you can cache the results somewhere. For the same queries, it doesn't go back. So if everybody's calling get me all services, you can optimize that on your database layer or your API layer. Yeah. Your second question.
So the fields that you want to have, you define client side, right? By determining what query you're going to do.
You define it in your schema. When you're querying, yes. Yeah.
So does that, are there specific security considerations there? Because it implies that you might be exposing things that would be visible to non-logged in users. So if you then do the wrong thing in the front end, you see that.
Good question. I didn't cover it in my presentation, but there is a security part to it. You can define security on top of each attribute or on your data model. And you can define which role are allowed to see this attribute, which role are allowed to see this data model.
Nice.
Other questions? Yes.
Can you do only simple queries, or can you also do conditional queries when you have to provide separate services to it?
Well, how do you mean? Can you give me an example?
A certain name starting with letter A.
Yeah, you can do that. Then you have to define the query as well. So this is like a search. Right now, I showed you find by ID and find all services, but you can also define a query says services by name and your parameter is a string, and you can provide in the parameter the opportunity to provide a star or a percentage, or even you say, I'm going to pick up everything starts with it or contains. So that depends how you implement your query execution, rather. But yes, there is an opportunity to do that. Other questions? Yeah?
You shortly mentioned pagination. Can you tell us roughly how that would look?
Pretty difficult, because your pagination has to be part of your data model. So if let's say your service, there are multiple rows in service, and you want to expose only 10 rows at a time. So you have to specify in your data model, just like ID, name, description, the page number or offset limit. Choose your weapon. Like some people are on the page side, some people are offset limit side. So you define that, and with each query you provide it. And then you get back that also as a result. And you can go one step further. You can also provide next page or a next offset, next limit, and resolve it on the backend side, that if you have an offset and limit like this or a page like X, you only query that. But yeah, you have to make it on your schema definition. It cannot come out of the box, to be honest. Yeah?
How would you compare GraphQL with OData? So do you see any advantages of GraphQL over OData or vice versa?
I wouldn't be able to answer that question. I never worked with OData, sorry. Yeah?
Is there a way of generating documentation?
Yes, the schema file is basically, you can define there all sorts of commands. You can guide the consumer how to consume it, basically. Yeah, actually, that's what you expose. Just like in OpenAPI, you can define all your commands in schema file as well. But it's like a YAML JSON file, so it's all with hash. Other questions?
Just one about the 200 responses, because now you have the RxJS library, for example, you have observable, and it will catch an error based on the status code you get returned, right? So how would you now solve that? Then
You have to.
everything in 200, you have to constantly check for error codes in your response.
Yeah, actually true. But it is part of your data model. So when you get it back, do I have still the example open? So when you get it back, you see there are two parts on your response. One is an error, one is an data. So you need to write a code to check whether my error is empty or not. That's the only way to do this, because GraphQL by design will give you 200. There's no way you can get another response code. So yeah, all the consumer libraries has to adjust that way, basically. Yeah?
I'm curious what the HTTP header looks like.
Sure, I can show you. This is all auto-generated, though. This is for Postman, though, but it's a good question, actually. Let me show you the REST client. So when I was invoking with the REST template, I needed to provide the content type as application GraphQL, to be honest. All the libraries has their own module to write the client, and they will add the headers for you automatically. So if you're interested, you can actually intersect there and check that. But from Postman, there is nothing special, actually, to be honest. And this is a simple post request, by the way. You can also do a get. Then you have to provide the whole body in the get parameter. Other comments, questions? Then we are before time. I wish you guys a good lunch. Thank you.